The MiniPro Dyno is primarily used for testing motors by spinning up the flywheel and logging the data on the software on the computer, which will show you the power, kV, all sorts of parameters can be recorded here. Another thing I use it for is testing speed controls and comparing them, so that's quite useful. But there is a third thing you can use it for, and that's for testing lipos if you want to, because you've got the interface here that measures voltage and current, and on the program there's another feature which is measures milliamp hours. So you can actually put a lipo on here, discharge it and measure its performance. So how do you discharge it? Previously I've used big resistor loads, which I've done videos on. There's a resistor load in here, and here is the sort of resistor load I'm talking about. Is high power 100 watt resistors arranged in parallel to give you a current draw for the battery you're going to test, in this case 2S, with whatever current you want to use. I discharge at 40 amps, and you arrange the resistance accordingly. Now that's just a resistor bank. I also have made up automatic ones which can turn off on their own, because when I test with this, normally I record the results, and when it gets flat I unplug it. Here's some results I've done previously, and I test the batteries as they discharge and measure the voltage with a voltmeter and a milliamp meter, and so I can compare their performance under load. It's a bit laborious as I have to watch the meter and write down the results as they occur. So using this, I can log the results in time versus voltage and current draw, and it also will measure the milliamps. Now if you just make a resistive load, what you do, you'll connect it, instead of these two connectors which go to the speed control, you'll just be connecting the resistive load to them. Then when you plug in the battery, the current will flow immediately. So what you can do, you can either have a switch, or you can just plug it in, or in this case it's automatically, it turns on and off with the press of a button, and at the end that one will turn off at set 6 volts. With a 2S you will stop discharging at the absolute minimum of 6 volts. You want to go below that, you can damage the battery. Some people turn off early at 7 volts. Anyway, that's a useful function. I'll just show you the program. Here's the program here. Up here you've got a drop down menu, and you can select various graph recording things here. Besides the voltage, various things versus time. You've also got things for measuring the motors down here, torque, kV, all sorts of things versus RPM. So we want the current, voltage versus time. Over here, to get it to record milliamp hours, you go to settings, and you've got again drop down tables. Here milliamp hours is that one there. It records other things, kV, RPM and temperatures. So I've recorded the temperature as well. There is a temperature probe here which plugs in, and I can put that on the battery just like that. It's a little IR1 infrared, and I can record the temperature. At the moment it only shows in Fahrenheit. Unfortunately, hopefully there'll be a mod do centigrade. Now the time is recorded here. You've got the graphs for current, well RPM we're not using, but we're looking at the voltage. To get it to work properly, you've got to select manual test up here. not automatic, which it'll do in a second. You have to connect the dyno. When it's connected, it's showing you the temperature in here at the moment, 73, and no current flowing. Now this voltage minus 0.25 is calibration voltage. I use a very accurate voltmeter, which is spot on. I put that on the battery, and then I set this to measure exactly the same voltage so that it's accurate. Then the reason for testing lipos now on here is that once I've got the baseline of a very good battery, and the best battery I've tested so far is a big 2S1, is a big Intellect 8400 high voltage. It held the voltage the highest always through the discharge compared to other ones. It held the voltage very high. There's a previous last year's one. This is 2018. This 2017 was same with the big 8400, and also the Nostrum 8000, which I think was the same battery, just in a different case, same results. And that I recorded the capacity and the temperature at the end of the run. The milliohm readings I can't get from this equipment, but I do get it from the iCharger. When I charge up, you can get, it's just been charged, a milliohm readings off of here. Find they're pretty accurate. So what I do is I charge up on the iCharger at 20 amps after being fully discharged. Ambient temperature battery to test. When that's fully discharged, I'll take it straight off and put it over here and do the discharge. So as I said before, normally I would do it manually. I used to use this one, which recorded recorded milliamps and volts. I'd plug in the battery and write it all down. Now I'm going to try and see how well this works. So we've connected. Over here you've got the manual test, and you can start logging in. You can do one test, second test, third test before and you can save them all, and then you can bring them up and compare them. As I said, I want the best battery I can find at the moment. For instance, this one, the 8400 IP. Get the result, and then you can compare all the others to it, see whether they're better or worse, and at what point. The current I'm going to use is about 40 amps, which I think is enough. In a race you will use about a 17.5 turn, will use about 2000 milliamp hours over 5 to 6 minute, 5.5 minute race. A 13.5 will use say 3000 milliamps, and very high power motors perhaps 4000 or 4 ampere hours. So we need to have quite a high current discharge to get meaningful results. And the battery that has the highest voltage, especially towards the end of a race, will be going the fastest, all other things being equal. So I'm just going to connect this up to the load and show you, start the sequence and show you what it does. I've connected up my load. This is a 40 amp resistive load. You can see some of the resistors inside. It's fan cooled, something I made myself. It's got variable auto cutoff. Can do 1S and 2S batteries. I can set 20 and 40 amps, and it's automatically, when I start this, it will run until it shuts off. Minimum 6 volts for a 2S. I can set it to higher if I want. Now that you don't need that exactly. As I said, you can build your own. I've done a video on how to build a load using high power resistors. They get hot, so you need them on a metal plate. You can buy these resistors on eBay, and you can work out the load you want, and just use that. You can just have it plugged up and to go, you would just plug in the connector to the battery and start it off. But in this case I'm going to use the auto one. To set the baseline to compare all other Lipos to, I've just charged up this IP8400 fully, and I'm just going to discharge it using, I'm going to start logging it in, voltage and current versus time, and also measure the milliamps. So I've got the voltmeter in there just to show you the exact voltage on here, how close it is. When I start this up, the resistive load's going to start up beeping, but let's just connect this up. Okay, it's 8.38. Start logging, press go. There's the time along the bottom in seconds, voltage of the cell in green, the amps there. Started at 50, just dropping back, and it's showing on there 42.5. The voltage has already dropped to 8, and on here it's showing 8 as well, so it's close to what it should be. Capacity, milliamp hours, going up, and you can see already 500 milliamp hours being used at 40 odd seconds, and so this will keep on recording till it goes flat at 6.0 volts. The load will switch off, and we get the baseline for the best Lipo I've got, 2018, which is the IP8400 high voltage, which was charged to 8.40 volts to start with. It's just discharging away. It's still holding about 39 amps. Temperature 89, 90. It's quite warm in here today. I did charge this battery up to 8.4.0. The internal resistance on the iCharger was shown at 1.5 milliohms per cell, perfectly balanced. So this will be the baseline voltage that every other Lipo I test can be compared to, whether the voltage under load is going to be better or worse, and at what point it becomes worse. So with a 17.5 turn motor, normally you draw about 2000 milliamps in a 5.5 minute race. As you can see, 120 seconds, 2 minutes. This is a heavier load than in a car normally. It's coming up 1500 milliamps already gone, and it looks like it's going to do about 2000 milliamps at about a 3 minute mark. The battery voltage is holding at 7.7 approx, and on the accurate meter it's showing 7.7. So actually the voltage that this is calibrated to is pretty accurate. It's coming up to 7000 milliamps discharge. The voltage is still at 7 volts, actual 6.9. It's just a fraction behind here. It's beginning to fall now. You can see the graph just starting to fall as it comes to the end of its period. The current's dropping too, voltage is dropping, 6.6, 6.5. It should shut off about 6.0, showing 6.4, 6.3, 6.2. It's close enough. So it's now shut off. The current's dropped to 0, and the voltage will recover. Temperature 134 degrees Fahrenheit, which, checking with this, is 43 degrees C. It's pretty warm. Actually, it's ambient in here is very high today, so that hasn't helped. I just let it recover a little bit, and then just recovered to 6.5. Capacity 7,304 it made, which I expected it to be around about that figure. So I can stop logging the data now. It reached 700, just over 700 seconds when it stopped. So I stop logging the data, and I'm going to disconnect the battery because it's beeping and making a noise. And let it cool down a bit. So now this is my baseline. Up here I can write the test description. At the bottom here you can actually call up the data, and you have to scroll left and right. So all the things at the beginning are for motors. So we're going along, and then we find the voltage and the current and the milliamp hours and the temperature all along here. So for instance, at if you want, and the time I believe on the right, so in seconds. So if you wanted to go to say 1 minute 60 seconds, go back along here, ambient temperature in here is hot, 80. Battery at that point was just fractionally off ambient. 702 milliamps at 1 minute have been absorbed, and the voltage at that point was still at 7.94 volts. And then if we go right down near the end, 6.14 when the auto shut off happened, and that was at 7,304. It was temperature 134 Fahrenheit, and the time there is 711 seconds. So some data there which can be compared on this screen here. I can hide the data, get a bigger screen. I can take away the current and just show the voltage, and I can expand and move the screen around, just showing there the voltage at the end. It was pretty dramatic. It was over 7.2, and then down it came to 6, and then off. So the curve, the battery's very good, held the power all the way to the end. Just a very small linear drop off, return to normal, and you can see time all the way along the bottom. So I've saved that already, and the next one you can get up to 3 results on the screen at once. A test on the Zombie 8000, a new pack, 120C, just been charged up, come off the iCharger. So we're going to start the test in a second. I'm just going to connect it up, start login, and press go. Voltage dropped to 8.04, current, as you can see, time must run along the bottom in seconds, and showing the voltage. I haven't got the amps ticked at the moment. Current 40 amps, and temperature 84. So when it's finished, I'll record the results, save them, and then bring up the control IP and see what sort of results we can show. I've recorded the data from the IP 8400 and the Zombie 8000, and to compare them. The green one's the IP, the red one is the Zombie. They're very close. I've expanded the graphs so they're virtually identical. So 7.4 volt line there at over 6 minutes, 380 odd seconds. and I can keep scrolling to the right till it gets to where it finished discharging, until we get near the end of discharge. 7 volts, 6.8 volts, and they're both pretty much flat at that point there. 705 and 715 seconds, and then they both recover as the amps has stopped. Now this data is also available down here. You can select the IP or the zombie, and if you had a third one up here, that would be on there too. You can have up to 3. You can select the time on the right. I've put it to 300 seconds, which is 5 minutes, and you can check the milliamps drawn, 3212 current, and the voltage at that point, 7.52 for the 8400. We set the zombie the same, 600 second mark there. We scroll back along and you find the voltage is 7.19 at that point, and the milliamps was 6107 drawn out. You could compare it at milliamps drawn, 6000 milliamps, voltage was 7.23, 7.23. We do the other one, 6000 milliamps for the IP, 7.29 volts. So you could use this data down here for comparing batteries up to 3, comparing at milliamps, time, and you can check at that point the temperature as well as recorded, 120. So these two batteries are very, very similar. So if you had another one that was much worse, it would show up a lot more. As you can see, if I go back to the graph, is not so detailed, 0 to 10 volts. Looks the same curve right down to there. So that's the use, or you can use for testing lipos and logging the data if you were going to compare them and see which one is better or worse or the same.